Welcome everybody. That was quiet, wasn't it? Oops. Okay, welcome everybody to another Autodesk Inventor tutorial. My name is Mr. Galindo. Apologies for the intro. Right, so we are nearly at the end of creating our CAM programs. You can notice here on the left hand side, since the previous cycles, there's two red X's on these programs. You just need to regenerate them. So I've gone to CAM, selected them both, click generate. Inventor's now populating them. At this point, you probably want to take a photo. This is one of the screenshot requirements of the passes. So this is the toolpath. So once these are generated, you'd want to select both of them and using the snipping tool, take a snip. Once this is done though, we'll actually simulate it and I'll show you a few things to look out for. The simulation actually allows us to check, once you specified fixtures, whether or not you're going to hit the fixtures with the bit, the cutter. And obviously we don't want to hit the metal fixtures, so that's quite an important step. Selecting them all here, this will be one of those options to take a screenshot. In your folio, I'd certainly be specifying what each of these toolpaths are and their purpose. Right, selecting all three though, clicking on, whoops, not generate, simulate, that's better, and then going to quality medium, that'll do, click play, 2 drill cycles, perfect, and then let's start increasing. Now while this is playing in the background, you'll notice down the bottom there's a big green bar. If you have any blobs of red on there, you need to come and grab your teacher. A red basically means that you have got a clash, and the clash is the problem. That's when it hits the fixture. And you can see from just watching that now, you've got your 3 passes going over, and we've got a really nice finish. Well, I say a really nice finish, a pretty good finish on our vehicle. I've changed the quality to extreme, and it's a little bit neater to actually what it is. But that's a nice quality finish there. Okay, perfect. Alright, so that's actually finished code. Now, rather than just exporting this, though we can, into the NC, or numerical code file that we need to plug into our router, or CNC, we need to actually create the right-hand side code. Now, fortunately for us, there is such a thing as copy-paste on computers. In this situation, we're going to be using a similar program option called duplicate. We're going to duplicate the setup folder, which gives us a second setup folder. Now, in the second setup folder, all you've got to do is specify the Y and the Z axes. Now, if we visually look at this from the bottom, and then we're going to go slightly on an angle, okay, the Z is above, the Y is to the right, and the X is back towards us. The vehicle rotates in the fixtures. The car gets automatically rotated, and you can see here that the Y and the Z go inverse, they're opposite now, but the X stays the same. So to be accurate for the second work coordinate system, for the right hand side, we need to flip those two so they're back the right way for our machine. And that's it. That's literally it. You just specify those two things, select your code, click generate, and you're done. Which is really easy. Okay. It used to be a lot harder, and originally back in the olden days, you had to write these kind of codes by hand. There were people who were trained to write what we call G code, and they would write everything out from where the tool had to move by hand. Fortunately for us, those days are over because that's a bit tedious and it wouldn't be much fun in a school. You can see here if I select the both parallel passes that there's 2, the whole car's covered. And that's basically it. We've created the codes that will manufacture the entirety of your vehicle. And if you've done it correctly and you simulate a setup at a time, you can't do both, you'll get that visible to you. You do want screenshots of those. The only thing I suggest you do is change the setup name to setup right, just for clarity's sake. Okay, having done that, we need to export the code. So you're going to select it all, and we're going to go to post process. This is the name we talk about when we export our program from a system like this, a 3D version, to an actual machine. Now, all these are different machines all around the world that people use to manufacture with, and it's just some of them, it's not all of them, but they use a specified language, and so we use the Denford CPS. Make sure it's not the generic Centroid because someone clicked on that last week and it did not end well for them. Denford CPS there, generic Denford, and that means that when they translate all this information into a single file, it works with our machine. The program name is up to you, but for me it's going to be tutorial cam tutorial. I probably should have put. I'm going to select the folder it goes in. I'd like this to actually go into my cam folder that's got all the files in. So under CAD, assemblies, cam, and that's where it's all saved. Select open, click post, it will generate it. You can change the names if you want to, so this will be number 1, and click save. Once it's done, it actually opens it up in a post-process viewer. That's quite interesting, and we have to modify it slightly because we haven't told the machine to rotate that block, our stock, around, so we have to do that. To do this, but first have a look at our code. This is our code. This is what we created. This is the language that we're using to communicate with our CNC. Pretty awesome. Pretty complex. Obviously, takes a little bit of getting used to. And you can see there's certain elements in it that are informational, like this. Drill 1, that's the drill program. Pocket 1, that's the pocket program. You could be guaranteed there's a parallel one. What we're going to do is we're going to go and customize this slightly. To do that, we're going to use the Control F program, and we're going to type in drill 1 again, because we duplicated the drill. So there's the first one, and then this is drill 1, and then it's in brackets 2, the second one. Now, just above drill 2, we're going to enter in a new bit of code. So we're going to click enter. And then we're going to use the macros here. And if you scroll down, these are all the G codes, and you can click on them and find out the information of what they do. But we want to do a machine 0 return to primary reference point. So that's the machine's home, not the program home, obviously. So we double click on that, and it enters the G28 for us. Then going to customize it because we just want the Z to go up slightly. We're going to go up another 4 millimeters before it starts doing anything else, and we want the A to turn into a 180 rotation. So we're typing in the A axis 180. This is basically the bit that's quite critical. Once we've done that, we scroll all the way down to the bottom of the code, and we find the G28 down here, which there is, right at the, whoops, I missed. Let's go cancel on the find. Right down the bottom, you see the G28 there, X0, Y0. We type in there A0 so that it rotates the fixtures back around the right way, and then we leave it. That's it. I'm just going to click save now, and that cam tutorial number 1.fnc file is the finished file that you open in the CNC and press play on, and it will move the CNC around and the cutter around like you've designed it to, hopefully producing your car. Fantastic. Well done. If you've gotten this far and you haven't gotten too stressed, or you've worked your way through reasonably quickly and efficiently, congratulations to you, because if this is a new system for everyone doing it, so it's obviously a little bit trial and error for a lot of you, and it shows great grit there getting through it all because it's quite complex. Good job. Alright, I shall endeavour to get these manufactured for you as soon as I can, obviously, and you'll need to come see me when you get up to this point. Right, thanks very much.